Good morning. Welcome and good morning to all of you out there. I'm excited that you're joining me as we learn about amazing aqueducts today. Today, we'll think through the lens of a civil engineer and build our very own model of an aqueduct. My name is Mrs. Bystrak, or Mrs. B. Whoops. Getting happy with those slides there. My name is Mrs. Bystrak, or Mrs. B, and I have the wonderful opportunity of working with students from the Chula Vista Elementary School District. Together, we get to learn and explore a variety of topics that are all related to water. So today's live event wouldn't be possible without the continued support of our friends at both Sweetwater Authority and Otay Water District. So I just want to give them a nice shout out and say hello to them out there. And hello to all of you as well. Now, during today's event, there are a variety of ways in which you can participate. Today, you're going to take on the role of a civil engineer, and you're going to build your own model of an aqueduct. We also have my friends Mr. Bruder, Ms. Lopez, and Mr. Ramirez, and Mrs. Quiros moderating in our Q&A section. So there you can leave all your appropriate comments, responses, and questions, and they are happy to respond and possibly share your responses out loud today. Finally, stick around and assess your knowledge and join us for our live Kahoot game. Now, today we're going to take on the role of a civil engineer. Civil engineers work to plan, design, and oversee the construction of major structures such as dams, bridges, pipelines, and water systems. Let's find out more about this exciting career that we're about to step into.
What is civil engineering? Civil engineers combine creativity with imagination and technical expertise to design our built environments. But as a civil engineer, what will you do? You'll be designing sustainable buildings and bridges that bring people together. You'll be developing transport systems fit for our future. You'll be benefiting humanity by providing clean water, energy, food, and shelter. You'll be building a world resilient to climate change and natural disasters. Civil engineers are improving the quality of the built environment for all. Are these things you want to achieve? You might become a civil engineer if you like developing ideas to change the world, applying maths and science in an imaginative way, collaborating with others to work through challenging tasks, questioning how things are designed and built, using technology to find the most sustainable solutions, and seeing your ideas turned into reality.
Awesome. So in that video, there's some really cool projects that civil engineers get to be involved with. Now, I bet many of you have created different types of models or prototypes and devices. So I bet you've joined us before, right? You've done some of these different engineering projects. So what kind of projects have you worked on that have helped to save a problem? So share with us in the Q&A. I'd love to hear some of those different projects you did. Maybe some of these pictures here might spark your memory. So again, in the Q&A, go ahead and tell us what engineering projects have you worked on that might have helped to solve some sort of problem. I can't wait to hear some of those cool things that you've already designed and built. Now, as we shift into the role of civil engineers, let's start off by talking about where we all live and work and go to school. Many of us are very proud to call Chula Vista, California, our home. In our community, we have lots of great attractions. We have great malls like Otay Ranch. We have great places to eat on 3rd Avenue. We're also home to the Chula Vista Elite Athlete Training Center. We have things like Sesame Place and the Living Coast Discovery Center. So we have such beautiful places, so many beautiful places. We have beautiful weather, great communities, and great schools. So it's no wonder why so many people live and call Southern California their home. Now, one of the things I love about San Diego and Chula Vista is the weather and the climate. But have you ever noticed, looking at this weather report here, have you ever noticed that we don't get a lot of rainfall? If we only relied on water from rainfall or rain that comes here and our local sources, we wouldn't have enough water to meet the demands of our community or our cities. Now, This is called water scarcity. So water scarcity is when we have a demand for water. We want to use that water for showers, brushing our teeth, for our lawns. But when that demand exceeds the available water supply, oof, that can cause some challenges. So imagine we have all these buckets to fill, but we only have a few drops of water. That's how you can kind of think about water scarcity. What would we do? How can we get enough water so people have the water that they need in our community? Well, we have millions of people in our region who need access to water. So if that supply doesn't meet our demand, like I said, it can cause some major challenges. Now, with those challenges, there's also a lot of opportunity for creative solutions and innovation. One way that we can try to meet the demand for water is having imported water or importing water. That's bringing water from one location, another area or region to our community. Now, imported water is water that's been transported to another area. Civil engineers have created what we call aqueducts to transport water over long distances. So you can kind of think of this aqueduct as like a man-made river, but it's a pretty intricate system using pumps and pipes so that we can get water to regions that have water scarcity. So today, when we build our aqueduct, we're building a device that can transport water from one source to another location. Now, like I said, aqueducts are a large system for carrying water from one place to another. Let's take a quick look at the Colorado River Aqueduct that helps supply a lot of water to Southern California.
It has been called one of the world's engineering wonders. The Colorado River Aqueduct carries water across the desert, over mountains, through tunnels and underground pipes to cities and communities throughout Southern California. The Colorado River Aqueduct supplements water from local sources and water from Northern California that flows through the State Water Project to meet the needs of Southern California's 19 million residents.
Yeah, so just watching that video, it's a pretty intricate system of pipes and pumps, getting that water to travel for a really far distance. So this type of project is one that a civil engineer or civil engineers have worked on in collaboration with many others to solve problems in relation to our water scarcity. So with that, we're going to jump into our roles as civil engineers, and we're going to build our own amazing aqueduct today. Now, before we do that, before we begin to build, let's go back and check in with Mr. Bruder to see what kinds of things you've designed or built as an engineer. So, hey, Mr. Bruder, how's it going today?
It's going very well. Good morning, Mrs. Bystrak.
Good morning, good morning. So what are our friends saying in that Q&A? What kind of projects have they built or designed?
Well, some of them, I think they recognize from your pictures or from previous live events, because Ava from Roar and Samuel shared making a solar oven, which I know is a popular project, and I believe Mrs. Hughes did that in a live event as well.
Yes, I see that. I'm looking at those s'mores in that solar oven is making me a little hungry for dessert in the morning.
We also had Mrs. Torres' class from Roar, 3rd grade class, share with us the fly fan that Mrs. Q did a few weeks back.
Ah, nice. Hopefully they were able to use it at some barbecues and things like that. I saw one in use at a restaurant the other day, actually at an outdoor garden restaurant, and they had some, but they were powered. They had electricity, so.
Awesome. And then quite a few people, Adrian, Jameson, Aviana, all shared making the claw one there.
So the one, I think it was Mr. Garcia had done that, right? Showing us different kind of like robotic arms and things like that. I love it. I love it. So students are tuning in and trying out these different engineering design projects. And so it's time to step in and become a civil engineer this time. You think we're ready, Mr. Bruder?
Sounds good.
All right. So with that, I know, a lot of problem solvers out there. So let's go ahead and get to this. So today, our problem is that water is scarce, or there's a small amount of supply or short supply in our region. So with that, we need to figure out a way to transport that water from one area to get it to our region to meet our demands. So today, we're going to build an aqueduct or a model of an aqueduct to show how water can be imported. Now, before we begin, I always start off by asking questions. I wonder what kind of questions you would ask before you design or make your model of an aqueduct. I like to think about lots of different types of things before I get started. So one question I might ask, or wonderings I might have, or how far must the water travel? So what's the distance? You know, I have to kind of think mathematically about that. How far or how long, right? To think about materials and supplies. We also have to think about what kind of materials and supplies might be best for transporting water. What's going to be sturdy? What can hold the weight of water? What's waterproof? What's not going to get inside the water, right? All kinds of questions there. But one of the major questions I also asked or was thinking about is how have people dealt with scarcity of water in other places or at other times? We can often learn from history. We can learn from other areas and regions. So if you want to share some of your questions, go ahead and share those in the Q&A as well. But let's go back and answer that last question. So I wanted to know, how have other people dealt with water scarcity and even in the past? So before we build, let's take a quick moment to learn a little bit more about the amazing aqueducts that the Romans engineered and built over 2,000 years ago. So check this out.
The challenge for the Roman engineers was to keep the water flowing at the same speed on its entire journey. To get around hills, they dug trenches along the contour lines and covered them with bricks and earth. To cross wide valleys, they funneled the water down through lead pipes and up again on the other side. To conquer high mountains, they dug deep tunnels right through them and shafts in their roof for ventilation. To cross long distances on even ground, they built flat walls with a trough in the top. And to channel the water into Rome without obstructing traffic, they built the majestic arched aqueducts we know today. These plumbed into a network of fountains that fed water to 1 million Romans.
So that video helps me kind of imagine what these aqueducts can look like. And so I think it's pretty amazing how we can transport water over such long distances. So a lot of those aqueducts that you saw, or the same plan that you saw there, are still in use in Italy today, where when you go to fountains, you can still use that water. So very similarly, here in San Diego, a lot of the water we use was transported by ways of aqueducts. Now, we can use those ancient ideas to help us plan our models. So here's a sketch of what we're going to construct today. On top, you can see a sketch of a Roman aqueduct. So without electricity, they were using gravity to help make that water go from one source to the end. And on the bottom sketch, you can see a very similar plan for a more modern aqueduct that uses pumps and energy, electricity to be able to get that water through long distances. So today, we're actually going to create our models to look like the part here that we have circled. So we're actually going to be doing this aqueduct bridge today. So with that, here are the supplies that you're going to need. So to construct our models, here's what you're going to need. If you're going to be testing with water, you might need some aluminum foil, but that's pretty optional. You might have a cereal box and a paper towel roll. That's one way you can create this aqueduct, but you can also have maybe 3 or 4 pieces of cardstock or some sturdy paper. We're going to use a marble or a small ball for testing today. You'll need a pencil so you can draw out some lines today with your ruler. So you'll also need a ruler or something with a straight edge. We also need scissors, tape, And if you're going to be testing with water today, which you'll probably end up doing this at home, if you're testing, then you might need 2 small cups, 1 with water in it, so you can test out your aqueduct today. Now remember, if you need to gather these materials, you can press pause and then press play again once you are ready. But with that, let me go ahead and get my materials ready. And it looks like we are ready to construct our models. So I'm going to go ahead and start off with my cardstock. Some of you have cereal boxes. If you have cereal boxes, what you're going to do is just kind of start cutting that box apart on any of those folds of the box. So wherever it's kind of folded, I would just go ahead and start cutting those. But what I'm going to do here with my 3 pieces of cardstock is I'm going to go ahead and start off by folding one piece in. So I think you guys call this like folding it like a hot dog bun here, so long ways. So I'm just going to fold it in half, and I'm going to use this to kind of mark a halfway point on my other sheets of cardstock. So I'm going to go ahead and mark this. I'm going to line this up as best I can. I want to try to have these as straight as possible, because it's going to make a difference in our flow of water, right? When we're cutting, making our aqueducts. I'm going to do that one more time for this other sheet here. There we go. Next, we're going to go ahead and just cut these sheets in half. So we're going to cut them in half. Some of you like to take the shortcut and cut them all at the same time, but that might make them a little crooked. So I'm just going to go ahead and cut all 3 sheets in half. I'm going to end up with 6 different pieces. Again, I'm trying to cut as straight as I can, just so that there might be more balance here. Or when I'm lining up edges, they're nice and straight. So next, what I'm going to do is I'm making a pretty long aqueduct because I want it to I want you to be able to have a bigger model where you can see the grade or the slope and see how gravity works. So what I'm going to do is take 2 of those pieces and I'm just going to tape them together. So I'm going to do that 3 times. So we basically cut our paper in half and we're just kind of rearranging it so we can make it a lot longer. Let me go ahead and do that for my other 4 pieces here. Some of you might still be cutting. Some of you might be helping your friends with tape there. I always try to have my tape ready so I can get it as I need it. And I'm going to do this one more time. If you need to reinforce it, maybe you want to tape on the back as well. That's really up to you. All right, I'm going to stick one of these to the side and I'm going to be working with these 2 pieces here. So the next thing that we want to do is, remember, we said gravity is the thing that helped that water flow in those ancient Roman aqueducts. So basically, you have to have the source higher, and then where you're sending that water has to be a little bit lower. So if we had this aqueduct straight at the top, that water's not really going to flow. So we want to be able to create an angle here. Now, if you were to create an angle, if I put my ruler like this, that water is going to flow very, very fast. And they said they tried to get that water to flow at the same pace or same rate over a very long distance. So I'm just going to make my angle a lot smaller here. So it's really tight at the top. And as we get further away from that corner, you're going to see how we have that grade or slope. Now, I just drew that line. I'm going to try to connect over here as well. I'm going to go ahead and do the same here. Just lining that up so we can see that it's going to kind of slope down there. So I'm going to go ahead and cut that piece off. And then I'm going to do the same on that second sheet. But we're going to use this one as a template so we know that they're lined up pretty well. Again, if you're still taping, things like that, you can pause this part if you're missing some of these steps. It's very tight at the top. There we go. So now I have my angle. I'm just going to get rid of this piece here. Now, when my aqueduct is going to these are going to support the aqueduct on the side. So the piece here on the other side, I'm going to go ahead and just draw that same angle and line and then cut it as well. There we go. I'm going to go ahead and cut that. So I'm recycling some paper here. You might notice it on some rice sack, thinking about things we love doing. Many of you are very hands-on learners. You like to build things, right, as engineers or problem solvers. All right, so I have my two pieces, and if I hold them up together, you can see that they're pretty straight and they're equal with one another. Now, the next part is this was going to be modeled after that Roman aqueduct bridge. So the next part, we want to add those arches. So they figured out how arches can use less material. You can have that passageway under where people can get past this kind of bridge, but the structure is standing tall. So arches are a great way to build, or you'll see lots of things built with arches. So I'm just using my hand and I'm just kind of tracing around it to get that shape. So I'm going to go ahead and do this maybe 4 times, 5 times, as long as I'm leaving some space there so that it's not too tight from arch to arch. All right, so I'm going to go ahead and cut those out. Lots of cutting today. Sometimes I don't follow the line because my fingers are probably so crooked that I want my arches to look pretty similar in shape. So we're going to do that on this sheet, and we're also going to do it on the next one as well. So everything on one side, we're doing on the second side as well. So now that I have those arches, I'm going to do the same thing. I'm just going to put this on top, use it as a template, and I'm just going to go ahead and trace where I'm going to cut on my second sheet. I'm just going to set that aside so I don't accidentally cut that one as well. You're probably busy cutting, you're busy taping, you're busy tracing. Lots of different things going on, I bet, in those classrooms right now. Maybe you're making a miniature aqueduct with just a small amount of paper. That'd be kind of cool to see too. All right, so now I have kind of my two pieces here. I'm going to put them together just so you can see them, how they're pretty much lined up equal on both sides right there. Now next, we're going to take that third sheet that we had put together, and what I'm going to do is I'm going to go ahead and roll it because we kind of want a curved top to our bridge where that water would flow. So I'm just going to kind of curl it. Some of you guys have a paper towel roll. You can just cut it in half, tape it together, and it's already going to have that curve for you. So if you brought the cereal box and the paper towel roll, you're probably using those flat pieces to make your aqueduct sides here, and then that toilet paper roll or paper towel roll to make the curved top. All right, now that that's pretty curved, we're going to start connecting these pieces together. So the first thing I want to do is, this piece is hiding because I kind of curled it over, is I'm going to line these two pieces up together, and I'm just going to go ahead and tape. Actually, I want to turn mine the other way so I don't see all of those words. So I'm actually going to curl mine the other way here. Just so I can have it white on the top. All right, there we go. Now I'm going to go ahead and just start taping. Again, I don't want any overlap. I just want it to be straight with those edges all touching. So I'm going to start off taping in the middle. I'm going to line it up over here, and then I can add more tape as reinforcement. And then, of course, we're going to do this again on the second side. So same thing on the other side. And just add more tape here. And then, as I think this through, I'm going to kind of fold this over so you can see how that's going to be this part that's going to make it stand. Just make sure I have my angles right, where I have it higher on one side and lower on the other. And then let me go ahead and just add some tape here as well. Don't want too much of a space, but I don't want it to overlap. So if I cut crooked, kind of like I did, that might be a little bit tricky. There we go. So you might have to straighten yours out a little bit if you were a little jagged with your cutting. A couple more pieces of tape here. Like I said, I don't want it to overlap. It'll be a little problem when I try to fold it and make it stand. All right, so we're going to kind of curl that inner part. We're going to fold these pieces down. I have to fold them a little tight just because I did overlap a little. So this is the part where you might have to do some adjusting to really make your aqueduct stand. Notice mine fell. So I'm going to use another piece here. There's different things you could probably do. You could probably connect these pieces at the bottom so that they stay standing together. I'm sure from that model that we saw, it's more of a sturdy pillar that's in here that you might be able to like create some kind of box out of paper or something. But for today, what I'm going to do is I'm just going to go ahead and tape down some of the bottom of these arches. So I'm going to tape them down so that we get that standing structure. So you can tape it to your table. You can be taping it to another piece of paper. You can try using those pieces you used from the arches. You can try using those to connect it together as well. So I'm going to get one side standing here. Let me see if I can get this other side standing. This is where you really have to do the problem solving with your device or your design, right? Your model. All right, I'm going to go ahead and add more tape to get this standing. This side's a little trickier. If you can see, I'm still just adding it. I have to do some folding and bending. We're almost done here. We'll be ready to test in just a moment. I'm going to test with a marble today so I don't get everything wet on my devices here. So the marble is going to kind of be able to show us if that gravity or force would be able to make the water go down. All right, so there is my design. There is my prototype. It might be a little shifty. If there was a lot of weight on it, it might collapse. So I might have to think of some improvements there. But let's go ahead and test this one out. I'm going to stick a marble on one end and see if it's able to roll down. So it has that grade or that slope. And so that marble is able to run down as if it was flowing like water. And because it's a really, it's not a steep grade, it's a little bit, it's just sloped very gently. It's not going too fast. Now imagine I tried to roll it up. Well, that water's going to come right back down. So this is kind of showing you how we can use gravity without electricity to make that water flow. So awesome. I bet a lot of you are still constructing yours. As you're doing that, I'd love to show you some of my tests where I actually tested with water. I know some of you might have foil. So if you're going to test with water today, you'll need those 2 cups. And all I would do is I would put some foil at the top of your aqueduct to kind of waterproof it so you're not getting that cardstock wet. I'd waterproof it, try to like push it down. And then here is my test when I used foil at the top. So let's watch that water flow. And there it goes. So imagine trying to get water from a really long distance. You'd really have to do a lot of planning. So I think it'd be cool if you guys try to figure out with your teammates or your classmates how you can connect your aqueducts together and get a nice slope and try to get water all the way from one place to another. I think it's a challenge you guys would be probably really good at. So with that, we always think about improvements we can make. So let us know in the Q&A from either the one I just built or what you're doing right now. Let me know how you might improve this design. So what would you do? Like I said, maybe some different materials. If I needed more weight support, cardstock's not going to be great, right? So maybe I would change the materials, or maybe I change the design of the bottom arches in some way. So let me know, what would you do in the Q&A to improve your design? Well, awesome. That brings us to our end here where we want to test our knowledge. You did a lot of work, a lot of learning about awesome aqueducts or amazing aqueducts. So it's time to test our knowledge in today's topic with a Kahoot. So in a separate window or device, so you can still see my screen, go ahead and go to www.kahoot.it and enter the game pin 796173. So again, our game pin is 796173. We should be adding that to the Q&A or into our chat right now. And as we do that, let's go ahead and check back in with Mr. Bruder and find out about some more of those engineering projects. So if their hands are free and they were able to type, I want to hear, Mr. Bruder, what other projects have students worked on? Or if anybody's already shared some sort of improvement they might make to the design we made today.
Hey, Mrs. Bystrak. Yep, I can definitely share a few of those. There were some I didn't get to share earlier about those engineering projects. We had a few viewers share how they built a tower before.
Nice, tall towers.
Yep, and those are always fun to do with like index cards. Have you ever built one with index cards before?
Yeah, we've done that kind of challenge with like minimal tape, right? And then suddenly wind comes or someone runs by and your whole tower goes kaput.
Few people shared about building a bridge as well.
So building a bridge. So just like a civil engineer, right? You just built one today, the aqueduct bridge.
Yep, some structural engineering too, I believe, is involved in that.
Yes, yes.
We also
yeah, with all those projects, it takes a lot of people, right? It's not just one career. It's not just the civil engineers. It's lots of people collaborating, working together to get those major projects finished.
Definitely. We also had a really cool one shared from Diego from the Innovation Academy about saying how his mom was making something to eat and she needed the recipe on her device. So it kept falling, so he went and grabbed some Legos and built a device that would hold it so it wouldn't fall anymore.
Ah, nice. There's so much you can do with Legos, right? I bet there's so many different types of projects that you can kind of turn. But I like that it was a problem and you figured out how to solve it, right? You looked at the available resources and materials and problem solved. And now I bet she's super happy and you're probably getting some good food out there now.
So we have a question for you, Mrs. Bystrak.
Uh-oh, let's see if I can answer that.
I know you see a lot of projects there at the hydro station and you've built a lot yourself. What has been your favorite engineering project that you've either built or seen built?
I think one that we've seen here or that we've done that I'm hoping maybe we can do live as well is kind of like that tall tower project where students, we give them a challenge where they're building a water tower. So water towers are put in an elevated surface so we can use gravity again. And I just love watching kids interact. We use like a water bottle, so it's really weighted. And so when students are working with materials, they really have to test it and keep improving. And so I love seeing that whole process of trying something and it fails, and then they try again and it fails, and they fail maybe 20 times. And then all of a sudden someone gets an idea and they're able to make it work and stand. So I think I enjoy the process maybe more than the actual project.
Speaking of fail, I was taught by someone a long time ago that fail is an acronym and it means first attempt in learning.
There you go. I love it. I love it. Right? Fail is not a bad thing as long as we reflect and we can learn and grow from it. I love it.
Most definitely. Well, I think we are ready to get this Kahoot game started.
All right, we're going to test all of your knowledge out there. So let's go ahead and start our Kahoot on amazing aqueducts. All right, question number 1. So think about the role you took on today as you were building and designing. So a blank oversees the construction of major structures. So is that a red triangle, software engineer? Is it an orange circle, civil engineer? Is it a blue diamond, product engineer? Or is it a green square, mechanical engineer? So think of the role you took on today. Think about the one we saw in this video. Who oversees the construction of major structures in our communities, or our cities, or our states, right? We have lots of big major projects like aqueducts. Is that going to be red triangle, software engineers, orange circle, civil engineers, blue diamond, product engineers, or green square, mechanical engineers? Think about the role you took on today, and let's see how we did. So for our first question, many of you saw that civil engineers can oversee the construction of major structures. I wonder if you guys are right too. There's lots of spread in these answers. Maybe those other people do, but today we took on that role of a civil engineer. All right, let's go to our next question here. Here's our scoreboard. It looks like we have Golden Sloth in the lead. Question number 2. Blank is when there is not enough water to meet the demand. So we're filling in the blank here. So when we can't meet the demands of the water, we have a certain term for it. And so is that red triangle, water scarcity? Is that orange circle, rainfall? Is it blue diamond, evaporation? Or green square, drought? This could be kind of tricky because we've heard lots of these terms and words. We're really looking for the one we talked about today, when there's not enough water in a certain region to meet the demand. We call it something. Is it red triangle, water scarcity, orange circle, rainfall, blue diamond, evaporation, or green square, drought? 10 more seconds there. Let's see how you're doing. About 10 more seconds. Is it water scarcity, rainfall, evaporation, or a drought? Many of you got that correct with water scarcity. Yes, so we can't meet that demand. Water becomes scarce. We have to be creative and innovative. Looks like Royal Yeti takes the lead. Question number 3 today. Blank is water that is transported from another area. So we're trying to figure out, what is that water called? How do we, what's the term we use for that? So is it ocean water that's transported from another area? Is it surface water is water that is transported from another area? Is it groundwater is water that is transported from another area? Or is it green square, imported water is water that is transported from another area? So we have lots of different water. When we're specifically talking about transporting water from one area to another, we call that water something, a certain term. Do we call it ocean water? Do we call it surface water? Do we call it groundwater? Or do we call it imported water? A couple more seconds to get those answers in. Many of you very quick. I saw those numbers going really fast as you guys were guessing or putting in your answers. 3 more seconds. What do we call water that's transported from another area? We call that imported water. Awesome, awesome. I wonder if our scoreboard's going to change here. Royal Yeti kept that lead. We had a shift down below. Question number 4. A blank transports water. So is this a lake transports water? A orange circle reservoir transports water? Is it a blue diamond aqueduct that transports water? Or is it a dam that transports water? So think about what we built, think about what we're doing today. We were importing that water from one location to another. Was that a lake that was transporting the water? Was that a reservoir transporting that water? Was it an aqueduct transporting that water or a dam? These are all words that are so closely related with water, right? We use them in so many different ways. They might be part of the system as well. 10 more seconds to get those answers in. Is it a lake that transports water, a reservoir that transports an aqueduct, or a dam? There goes those final answers. Looks like many of you got this one correct. It was Blue Diamond, and aqueduct is used to transport water. One of the ways we transport water. Cheerful Lemur took the lead. Let's go to question number 5. Question number 5, this is our final one. I guess these are more fill in the blanks than they are questions. So aqueducts can use blank to help water flow. So we talked about how we can get water to flow without electricity or pumps and pipes like that. So aqueducts can use, is it red triangle plants? Do they use orange circle gravity? Do aqueducts use blue diamond rivers or green square windmills? So how do we get that water to flow at a constant pace? We have it angled and certain force is helping us, right? Get that water to another location. So was it red triangle plants to help the water flow? Was it orange circle gravity? Was it blue diamond rivers? Or finally, green square windmills? Think about that force that we used. What helps that water flow? And our answer here, many of you got that as well. It was gravity. Gravity is used with these aqueducts to help the water flow. Let's go ahead and check our podium. That was our final question. In third place, we have Gentle New. Or GNU. We have, oh gosh, these words are hard. Silly Oryx in second place. And in first place, who ended up taking the lead? Cheerful Lemur kept that lead right there. Awesome job. Awesome. So I wonder if you guys are still building out there, still adding some of those different improvements. So keep on working. Thank you for joining us today. If you enjoyed today's event, don't forget, subscribe to our YouTube channel. It's at CVESD Innovation and Instruction. So there you'll find a collection of all of our previously recorded projects. So if you want to work on more engineering projects or improve them, go and join our YouTube channel. It's hard to say. So I hope you have a chance to join my friend Coach Ramirez on September 9th as he presents another live event for you. So he always has something fun. We always learn about things that make us more healthy, more fit. So I can't wait to see as we join Coach Ramirez on September 9th. Well, with that, I hope you guys all have a safe and healthy weekend. Remember, today we talked about water scarcity. We have a short supply, right? And so let's all do our part to help conserve or use less water. Have a good afternoon, everybody.